Okay, so in this demonstration, I'm going to show you convection, thermal energy transfer by convection. Remember, convection is when the hotter liquids and gases rise to the top and the cooler liquids and gases sink to the bottom. So here I have a water bottle. The water bottle does not have any openings. The top is closed with this balloon, and inside the water bottle there are air particles that are floating around. Air particles are in the gas state and they're floating around the water bottle. And over here I have a cold water beaker, and the temperature of the water is around 78 degrees. And here I have a beaker with very hot water. The temperature is around 278 degrees. So let's see what happens when I put my water bottle inside the cold water. So when I put the water bottle inside the cold water and we wait a little bit, nothing much is happening because the temperature of the cold water and the temperature inside the water bottle, they're around the same. They're around room temperature. So not much thermal energy transfer will happen. Now let's see what happens when I put my water bottle in the hot water beaker. Alright, so as soon as I put the water bottle in the hot water beaker, the balloon inflated and it rose up. And why did that happen? Well, the particles in the hot water have a lot of thermal energy. So they're going to transfer thermal energy to the air particles inside of the water bottle. And as the air particles start to gain thermal energy, remember, they get hotter and hotter, and we learned that hot fluids like gases and liquids will rise to the top. So all of the air particles in the balloon, as they gain thermal energy, they get hotter and they start to rise to the top and fill up the balloon. So our balloon inflated. Now when I take it out of the hot water and put it in my cold water, let's see what happens. So in the cold water, the air particles are going to start to lose thermal energy to the cold water. And we learned that cold fluids are going to sink to the bottom. They will float to the bottom. So now you see that the balloon is starting to deflate little by little. It's losing thermal energy, and colder fluids sink down, so the balloon will no longer stay inflated. So if you wait a little longer and wait for the thermal energy to transfer out of the water bottle and into the cold water, you should see that the balloon starts to deflate. There we go. So the balloon is deflating because it's losing thermal energy. So then the particles in the balloon are going to sink to the bottom of the water bottle since cooler fluids sink down. And one more time. Cooler fluids sink to the bottom, so the cold air particles started to go to the bottom of the water bottle. And when I put it back into the hot water bottle, the balloon starts to inflate again because the hot air particles will start to rise to the top.